Good day. Today we are going to discuss about trigonometry. So the objective for this topic is we need to find the unknown sides and unknown angle in a triangle. So what is trigonometry? So trigonometry is concerned with the connection between the sides and angles in any right angle triangle based on this illustration. So the sides of a right angle triangle are given special names. So we have the hypotenuse, the opposite, and the adjacent. So when we say hypotenuse, it is the longest sides and it is always opposite with the right angle based on this illustration. The opposite and the adjacent sides refer to another angles other than 90 degree. So what is the difference between the two? When we say opposite side, it is opposite with the given angle or theta. And when we say adjacent, from the word adjacent, meaning that is nearby. So meaning that is nearby with the given angle. Again, when we say hypotenuse, it is the longest side and it is always opposite with the right angle. When we say opposite side, that is opposite with the given angle. And we have the adjacent. When we say adjacent, it is nearby with the given angle. So please remember that concept, because if we go beyond to our discussion, that is very useful. So we have the trigonometric ratios. We have the three trigonometric ratio, the major. So we have the sine, cosine, and tangent. So when we say sine theta, that is equal to opposite over hypotenuse. And when we say cosine theta, that is adjacent over hypotenuse. And when we say tangent, that is tangent theta, that is opposite over adjacent. Again, the sine theta, that is opposite over hypotenuse, cosine theta, that is adjacent over hypotenuse, tangent theta, that is opposite over adjacent. So we need a way to remember all of these ratios. So this one is, in order for you to remember, we have the SOHCA TOA, meaning SO means sine equals to opposite over hypotenuse, CA means cosine equals to adjacent over hypotenuse, TOA means tan over opposite, tan theta equals to opposite over adjacent. So using the trigonometry on the calculator, all individual angles have different sine, cosine, tangent ratio, or decimal values. Scientific calculators store information about every angle. We need to be able to access this information in correct manner, of course, for us to get the correct answer. Finding the ratios. So the simplest form of question is finding the decimal value of the ratio of the given angle. For example, if we have sine 32 and we need to use your calculator, so just click sine, then 32, then equal sine. By the way, 32, that is the angle. And we have the 0.5541, that is the ratio or the radian. Using ratio to find the angles. We have just found that a scientific calculator holds the ratio information for sine, cosine, and tangent for all angles. It can also be used in reverse, finding an angle from a ratio. To do this, we use if you are going to read that one, that is the inverse of sine. So if there is a negative 1 above of the sine or any ratio, that is inverse. Inverse of sine, inverse of cosine, and inverse of function k's. Example, we have sine x equals to 0.115. Find the angle x. Again, x is the angle, 0.115 is the radian or the ratio. So we need to find the angle. So in order for us to get the angle, we need to get the inverse of the inverse of sine 0.115. So how to do that using your calculator? Just click Shift Sine. So that is the result. Open parentheses, put the ratio 0.115, then close parentheses. So that is, it will yield to x is equal to 6.4 degree. So meaning, the measure of angle x is 0.4 degree. 6.4 degree. Another example, if we have cos x, which is equal to 0.8988, find angle x. So the same process with number 1 example, get the inverse of cosine, 0.8988, by clicking Shift Cos, then close parentheses, 0.8988. So that is equal to x equal to 26 degree. Finding an angle from a triangle. To find the missing angle from a right angle triangle, we need to know the two sides of the triangle, of course. So we can then choose the appropriate ratio, sine, cosine, or tan, and use the calculator to identify the angle from the decimal value of the ratio. Example. So in this illustration, we need to find the angle C. So in order for us to find the angle C, we need to identify or label the names of the side in order for us to choose the ratio that contains both of the letters. So by this example, 14 centimeter is the hypotenuse because again that is opposite with the right angle. 6 centimeter is the adjacent because that is nearby with the angle given, C. So we need to use the cosine. So meaning cosine A or theta is equal to adjacent over hypotenuse. So use the formula. Then substitute. As you can see, C, since our given angle is C, we substitute C from A equals to adjacent is equal to 6 centimeter. Then the hypotenuse is 14 centimeter. Then divide. So cos C is equal to 0.4286. Are we done? Not yet, because that is ratio, not an angle. So we need to inverse the cosine in order for us to get the angle C. So again, the same process before. Click shift, then cosine, open parentheses, 0.4286. So the result is angle C is equal to 64.6 degree. Another example. Find angle X. Again, identify or label the name of the sides. So based on the illustration, so 8 centimeter or that 3 centimeter, that is the adjacent because that is nearby with X. And 8 centimeter, that is the opposite side because it is opposite with the angle X. So we need to use the tan because it contains opposite over adjacent. Copy the formula or the equation, then substitute. So we have tan x, because x is our theta, equals to 8 is the opposite over the adjacent 3 centimeter. Divide. So the result is tan x equals to 2.6667. Then get the inverse of tan in order for us to get the angle x. Then click equal sign, which is equal to 69.4 degree. So that is the angle x. Another. So in this illustration, we have sine. We need to use the sine, that is opposite over the hypotenuse. So sine A is equal to, the opposite is 10 because that is opposite of y. Then the hypotenuse is 12 because that is opposite with the right angle. Divide, that is sine x is equal to 0.8333. So get the inverse of sine. So the result is x is equal to 56.42 degree. Find a side from a triangle. To find a missing side from a right angle triangle, we need to know one angle and one other side. So note, if cos 45 equals to x over 13, to leave x on its own, we need to move the divide 13. So it becomes a times when it moves. So, or just simply cross multiply. So we have cosine 45 times 13 equals to x. So example. So identify the label. So we have 7 centimeter is the hypotenuse and k is the adjacent. And our theta given is 30 degree. So we need to use the cosine theta, which is equal to adjacent over hypotenuse. So copy the formula, then substitute, then cross multiply. So what we have is cosine 30 is equal to k over 7. Then cross multiply cosine 30 times 7. So we have this, then multiply, that is, get the cosine 30 times 7, and it yields to 61 6.1 centimeter. So K is equal to 6.1 centimeter. Another example. So we need to find the value or side R. So identify the given. So we have the given, the theta is 50 degree, and the the adjacent is 4 centimeter, and we need to find the the opposite, which is R. So we have been given the opposite adjacent, so we use tan. So tan A is equal to opposite over adjacent. And then substitute. So we have tan 50 degree equals to opposite, which is R, and the adjacent is equal to 4. Cross multiply. So that is 4.8 centimeter R. Another example. So we have, based on the illustration, we have 12 centimeter, which is the hypotenuse. K is the opposite. Then the given theta is 25 centimeter. So we have been given the opposite and the hypotenuse, so we use the sign. So sine A is equal to opposite over hypotenuse. So sine A is equal to opposite over hypotenuse. Then substitute. So sine 25 equals to K over to 12. So sine 25 times 12 equals to K. So the result is 5.1 centimeter equals to K. So the opposite side, K, is equal to 5.1 centimeter. Find a side from a triangle. There are occasions when the unknown letter is on the bottom of the fraction after substituting. So example, cos 45 equals to 13u. So this one, or the unknown side, is in the bottom. So just simply move u term to the other side. It becomes a times when it moves. So cos 45 times u equals to 13. So we are not yet done. So to leave u on its own, move the cos 45 to the other side. It becomes divide. So it becomes u equals to 13 over cos 45. So when the unknown letter is on the bottom of the fraction, we can simply swap it with the trigonometric sine A, cos A, tan A value. Example. So cos 45, and we have u, just simply swap. So that becomes u equals to 13 over cos 45. So that is the shortcut method. So example. So if we have x, which is the hypotenuse, and 5 centimeter is the adjacent, and we have the given theta 30 degree. So what trigonometric ratio we are going to use? So cos A, which is equal to adjacent over hypotenuse. So substitute. So we have cos 30 degree equals to 5 over x. Take note, x is in the denominator. The same, swap x to 30, cos 30. So that is 5 over cos 30. So using your calculator, it will yields to x is equal to 5.8 centimeter. Another example. So we have 8 centimeter, which is the opposite, and the hypotenuse is m, or the unknown value. And our theta is 25 degree. So sine A is equal to opposite over hypotenuse. So sine 25 equals to 8 over m. So swap m to sine 25. So that is m equals to 8 over sine 25. So m is equal to 18.9 centimeter. Now on your screen, it's your turn. It will be submitted. You are going to submit that one next week. So see, copy in the screen. You copy this one and you answer that one in a one sheet of paper. I hope you learned something from this video. Stay safe and God bless.